Thanks for joining me. So I'm looking at the longest common prefix problem today, and I decided I wanted to do a little bit of testing because I've run this problem before, and what I have for a solution here is not included in any of the answers as a different approach. And I just noticed it ended up somewhere on the execution and performance metrics, and I thought, I think this should be much slower than it is. So it just got me to thinking, I want to try a few things out. So it's time to do some testing. So what I'm going to do is I'm going to run this bit of code that I wrote right here. I'm going to take a look at how it does. So I expect this to be pretty slow because this arrays.sort up here, I think that's supposed to run nlogn. And if we look at the documentation quick, we look at these sorts. Implementation note, this implementation is stable, adaptive, iterative merge sort that requires far fewer than n log n comparisons when the input array is partially sorted, while offering the performance of a traditional merge sort when the input array is randomly ordered. Okay, a traditional merge sort, n log n. So it should be pretty darn slow. What I'm gonna do is I'm gonna run this probably 5 times or so, just because there's variability on the results. How HackerRank, or excuse me, oops, how LeetCode runs these things. It's probably going to bounce around a little bit, and then I'm just going to document it in a spreadsheet. Let's take a look. Okay, that jumped around a little bit more than I would have expected, but at least there's some consistency between a few of these numbers. Memory usage is, I expected that one to be the same exact every time. It is not. That's really strange. But I think the execution time, maybe there's something to explain that, but I can't explain it right now, so let's see how the rest of these pan out. Now I'm going to take the solutions to this problem offered by LeetCode, and I'm just going to enter them all. I'm going to see how they perform and just do a comparison between them that way. Okay, horizontal scanning, smoking, man. Looks optimal. All right, vertical scanning's looking optimal as well. Noticing a trend here. Probably as we now suspected, it's fast, just like the other ones. So it looks like maybe mine's slow and just the only one that's slow. But somehow, it ends up being maybe faster than what other people have done. I'm going to retry these sort compare first and last, or at least that's what I'm calling my solution, and see if something hasn't happened, if LeetCode hasn't responded to the enormous battery of tests that I've performed. See how that turns out. Running the solution that I came up with again for another 5 trials, I see our times are very similar as before. So it seems like LeetCode doesn't have the resolution to really tell us how fast our solutions are or not in this problem, because of the consistent 2 answers that we're getting when performing my code solution. It appears that we're falling into a particular bucket in terms of time performance in the 63.28 execution time percentile case and the 100 execution time percentile case. And I think it's made a little bit more clear when we take a look at the details. And here we can see the buckets of our distribution from 0 to 1, and then 1 to 2, 2 to 3, and so on. And so essentially, what we can see here is from 0 to 1 is where all 4 of the solutions that are given by LeetCode exist. There's probably an entire curve within this one bar. We can't see it because the resolution of the test isn't good enough. Milliseconds is what we're seeing, and maybe we'd have to get down to nanoseconds or microseconds, something like that. And with the way that this test is set up and the test suite that LeetCode provides, we can't see that. To follow up this video, I'll be using system.nanotime and testing things locally
to see something meaningful in terms of time performance between the 4 solutions offered by LeetCode. That's going to do it for this video. Keep an eye out for the follow-up. And if you like this video, give it a like. If you're new here, subscribe. And I will see you in the next one.